Okay, so let us continue from where we left off. I was just looking at the previous वाले notes. तो मिल गया था ना notes मैं भेज दिया था ना मेरे को ग्रुप ही नहीं मिल रहा था तो मैंने किसको भेजा था मैंने स्मिथ स्मिथ को भेजा था मिल गया था गुड ओके सो in the last वाला I think I was talking about uh, magnitude of friction for which I told you that there is no requirement unless and until somebody forces you to say, please tell me the boundary condition, or someone says that the thing is just about to slip or is just slipping, then you say that, okay, fine, now I can take the value of friction as mu n. Otherwise, you will always take it as some unknown f. Direction of friction, I told you that it really does not matter. Okay, and I hope you were convinced in the last class that you can take the friction anywhere you want and you'll get the answer. Right? Now, in the direction of friction, I told you the long wala method, but I don't think I told you the short wala method. So I'll tell you that. But like I said, it is not always valid. Okay. Uh, Although I will tell you the thing. And then finally, we must discuss what is the point of action of friction on the rigid body. Right now, you already know this. Point of action has to be the point of contact. I mean, ऐसा नहीं हो सकता है कि ये पेन मेरे हाथ में ऐसे रखा है तो फ्रिक्शन इधर कहीं लगने लग जाए ऐसा नहीं फ्रिक्शन यही लगेगा जहाँ पे ये पेन मेरे हाथ के कांटेक्ट ओके सो the shortcut first quickly shortcut uh, direction of friction please remember does not always work. So you can say that you can use this every time, no problems, but so let's say that we have force F acting on the subject, right? So what we do is we draw the FBD without friction. Okay, so there is F, there is mg, there is n. Right? So just like before, draw the FBD without friction. Okay, and then all you have to do is ask yourself a single question. Is there a torque acting on the system in the absence of friction? So there are obviously two choices. One will be that there is no torque, and the other will be that there is torque. Okay? Basically, what I mean is that you take the object and you any force if it is passing which is not acting through the center of mass, that will produce the torque wala case. And if all forces are acting from the center of mass, that will produce the no torque wala case. So if there is torque, okay, then friction opposes the torque. You can forget about the forces, you can forget about everything else. You can just say, अच्छा उसके ऊपर clockwise torque लगा है तो फिर friction anti clockwise torque लगा है इसके ऊपर एंटी क्लॉकवाइज टॉर्क लगा हुआ है तो फ्रिक्शन फिर क्लॉकवाइज टॉर्क लगा है और अगर टॉर्क नहीं है right? If there is no torque, then the absence of friction must indicate a net force acting. Okay, ठीक है, rotate नहीं करेगा, but absence of torque will tell us that there is a net force acting on the object. So in this case, friction will oppose um, net force. Again, I'll show you both the cases. So in this case that I've drawn, in the absence of friction, is there torque or no torque? What is the case? In the case that I've just drawn, is there a torque on the FBD or no torque? Is there a torque on the FBD or no torque?
There is a torque.
So if there is a torque, then is it clockwise or anti-clockwise? If there is a torque, then it is clockwise or anti-clockwise?
Clockwise.
It is absolutely right. It is, yeah, everybody's right. It is clockwise. So the friction must be providing an anti-clockwise torque. Friction must be providing an anti-clockwise torque. Therefore, this must be the direction of friction. Okay. Therefore, this must be the direction of friction. हाँ, बिल्कुल सही पार्थ. So Parth is saying it depends on net acceleration of the bottom point, and that's right. You can of course go with the long method. I showed you the long method in the last class. If you have time on your side, then of course you can go with the long method. But again, जो चीज काम में आने ही नहीं वाली है, उसके लिए इतना नाटक करने की क्या जरूरत है ना? Okay, so let's draw the FBD for this guy. So we have, what are the forces acting on this guy? We have mg and we have a normal reaction N. Is there a torque on this or not? Is there a torque on this or not?
There is
No, sir.
Remember, yeah, remember this FBD is drawn in the absence of friction. Friction will produce torque or not, that is a separate question altogether. In the absence of friction, whether there is torque on this or not, that is what you have to answer. So in the absence of friction, there is no torque, right? So therefore, there must be a net force, and if you keep anything on a inclined, an inclined surface, there is a component of mg acting downwards. Remember, it is mg sine theta. So there, in the absence of friction, there will be a net force in the downward direction, down the incline. And in the absence of friction, it will simply slide down the incline. Therefore, friction must be opposite to this force. In fact, any cylinder on an incline has upward friction. Okay, cylinder or sphere or whatever you want. अगर वो inclined पे है, so it will always have an upward friction. In absence of external agents. So if you don't have, people applying force on this, and only gravity is there, and normal reaction is there, then whatever happens, friction will be upwards. Okay, this is the. But remember, it does not matter. Okay. So let's do some questions and then we'll be ready to handle work per energy. Question number 1. Find A, acceleration of cylinder, hollow sphere and solid sphere down an incline of angle theta. D. Also, so this is no slipping. By the way, सबका FBD बना के ये बना हुआ है, सबका FBD बना हुआ है, right? I mean, I have already made the FBD for the question here. Also, find limiting values of mu for these three objects so that slipping just occurs. Right, so basically in part A, I'm telling you to take friction as F. In part B, I'm telling you to take friction as mu n. Okay, chalo, please do this quickly. कौन है वेटिंग रूम में भाई?
सर वो मैं पहले था वेटिंग, मैंने आपको मैसेज किया।
आजा, था क्या? भाई मेरे को लगा मैं तो डिसेबल कर दिया। भाई पाथ सॉलिड भी है, हॉलो भी है भाई। पार्थ आपका आंसर गलत है because we are talking about rolling objects, right? They are rolling down. Their acceleration cannot be the same as objects who are sliding down. सबका निकालो जोएब, सबका निकालो। हाँ बिल्कुल फ्रिक्शन का टॉर्क आएगा, यस। basically I want 6 answers, okay? I want 3 accelerations and I want 3 values of mu. Very good, sir. बहुत बढ़िया. ये क्या है? The answer should not contain F, right? F is an unknown. बिल्कुल सही उत्कर्ष. गाइस सब लोग करो यार कॉपी में. वेरी गुड सत्यम. यस. प्लीज टेल मी द वैल्यू ऑफ म्यू. वो याद है हमने उसके लिए निकाला था. आ, अगर एक ब्लॉक है kept on an inclined plane, so what should be the limiting value of mu that it slides down? And the answer was mu is equal to tan theta. So if I keep it less than mu is equal to tan theta, right, the friction will not be sufficient to stop the slide. So in the same way here, I want to find that limiting value of mu for which the objects will, they will start slipping. So basically everything will remain the same except अब आप f का वैल्यू उसमें म्यू एन डाल दोगे और आपको एक बार n का वैल्यू निकालना पड़ेगा. Once you've done that, हाँ बिल्कुल सही. बहुत बढ़िया जोएब, yes. Okay. So like I said, I've already drawn the FBD. Okay, so the FBD is something like this. हाँ, I am right. अच्छा नहीं आ रहा है क्या? एक मिनट. I'll just stop the share. हाँ, अब आएगा. So बहुत बढ़िया आपका. Yes. Now I don't want to solve all the three problems. What should I do? Can anyone help me out? I don't want to solve all the three problems. Okay. So I'm going to
मोमेंट ऑफ इनर्शिया को बस आई रखते हैं, लास्ट में फिट कर लेंगे.
उससे भी बेटर मैं बताता हूँ. So there is something called the radius of gyration. Very very simple concept. बहुत ही आसान. So it simply says that for any object, keep the moment of inertia equal to mk square. Right? Keep moment of inertia equal to mk square, where m is equal to the mass of the object. Then k is equal to radius of gyration. Okay? So instead of saying, for a cylinder, K is equal to R by root 2. Therefore, moment of inertia of a cylinder is equal to m into R square by 2. For a hollow sphere, K is equal to root 2 by 3R. So, moment of inertia of a hollow sphere is equal to 2mr square by 3. Right? For a solid sphere, K is 2 by 5R. Therefore, the moment of inertia of a solid sphere is 2 by 5 mr square, and so on and so on. Right? So that's just a shortcut, so that I don't really have to bother about moment of inertia क्या है क्या नहीं है. So I'm going to use this concept. So for this guy then, for this guy, I will write, since the motion is translation plus rotation, I will write for translation mg sine theta minus f is equal to ma. And for rotation, I will write down fr is equal to I alpha. And for the constraint, they've already discussed. अगर हमारे दिमाग में कुछ नहीं आ रहा है या हमारे पास टाइम नहीं है, तो we simply go for A is equal to R alpha. So therefore, the equations that I get will be mg sine theta minus f is equal to ma. F r is equal to nk square into alpha, which is a by r. So this would mean that f is equal to mk square by r square into a. And I can add these two guys. Friction will go away. And I'll end up with mg sine theta is equal to a common आ जाएगा m plus mk square by r square. Therefore, a is equal to g sine theta divided by 1 plus k square by r square. So therefore, acceleration of cylinder will be equal to g sine theta upon 1 plus k for cylinder is r by root 2. Okay, so this will be 1 by 2. So this will be 2g sine theta by 3. नहीं, आर अल्फा के अलावा रजत नहीं लगेगा ना इसमें, क्योंकि आप उसको देखो ना, जो पॉइंट ऑफ वो है, जो पॉइंट ऑफ कांटेक्ट है, पॉइंट ऑफ कांटेक्ट का एक्सेलरेशन ड्यू टू ट्रांसलेशन तो ए हो जाएगा, और इनका जो अल्फा है वो ऐसे है, इस पॉइंट का आर अल्फा ड्यू टू रोटेशन हो जाएगा. So this is due to translation and this is due to rotation, right? And इस पॉइंट का और इस पॉइंट का एक्सेलरेशन सेम होना चाहिए, right? So A is equal to R alpha ही आएगा. Like I said, this like I said, close your eyes and put A is equal to R. Unless of course there are, अभी इसके बाद I'll give you a question where A will not be equal to R. Okay. So now you see, you can figure out the A for everything just by putting in the value of K. Now, for the limiting value of friction, okay, what will I do? What will I get? Well, equations will be same. Equation में तो कोई फर्क ही नहीं आएगा, except for the fact that here, right? मैंने क्या किया? मैंने ऐसे coordinate axis ली हुई. यहाँ पे मेरा component आया mg sin theta. Obviously यहाँ पे जो component आने वाला है, that is mg cosine theta. So everything remains the same. Everything remains the same. There is no difference in the equations. There is no changes in the equation, except for the fact that for translation now, you are going to get n is equal to mg sin theta. So basically the equations that we are writing now will be mg sin theta minus mu n is equal to ma, right? And mu n will be equal to that
mg cos theta.
mu mg cos theta, right? Now we have already found the value of a. A तो ये रहा, हमें a तो पहले से मालूम है, a की वैल्यू यहाँ पे डाल देते हैं. So this will become mg sin theta minus mu mg cos theta is equal to ma, which is equal to m into g sin theta upon 1 plus k square by r square. So m cancel हो गया, g cancel हो गया. मेरे को तो केवल म्यू की वैल्यू चाहिए, तो कोसाइन थीटा से मैंने डिवाइड कर दिया. सो आई गेट tan थीटा minus mu is equal to tan theta upon 1 plus k square by r square. So mu is equal to tan theta 1 minus 1 upon k square, sorry, 1 plus k square by r square. Right? So for a for a cylinder, get mu is equal to tan theta into इसको कैसे लिख सकते हैं? 1 plus k square. So you can write this as k square by r square upon 1 plus k square by r square, which will be equal to tan theta into 1 by 2 upon 1 plus 1 by 2, which is equal to tan theta upon 3. This is the limiting value of slipping. इसका मतलब ये हुआ कि अगर मैंने एक सिलेंडर को एक इंक्लाइंड प्लेन पे रखा ऐसे, right, and if the value of mu is less than tan theta by 3, then it will not roll down, it will sort of roll and slide down, it will slip. And similarly you can work out for and you should, in your copies this should be written, for hollow cylinder कितना होएगा and for solid cylinder कितना. ठीक है ना? एक ये गर्म हो रहा है. Anybody having doubts in this, please tell me. हाँ, a is equal to r alpha valid कहाँ नहीं है, यहाँ पे आ रहा है. We are coming to this. We are coming to this. ये इसमें किसी को डाउट? हाँ सही. Okay. Next question. Now here a is equal to r alpha will not be valid. So the question is, we only use radius of gyration when multiple related question. No. Radius of gyration is basically a way of me being lazy. So instead of telling you that we are dealing with a sphere, we are dealing with a hollow sphere or solid sphere or cylinder, I'll just tell you that look, the radius of gyration of the object is r by root 2. That's it. खत्म हो गया. तो आपको मालूम है कि अब उसका मोमेंट ऑफ इनर्शिया mr square by 2 है. This is especially useful when the axis of rotation is something different. तो एक डिस्क है, वो किसी और एक्सिस के अबाउट रोटेट कर रहा है, उसका मोमेंट ऑफ इनर्शिया कुछ और है. नहीं, याद नहीं रखना है बच्चा. आपको जो याद रखना है वो पहले बता चुका हूँ. सिलेंडर, रिंग, सिलेंडर, होलो स्फीयर, सॉलिड स्फीयर, राइट. रॉड, थिन रॉड एंड रेक्टेंगल, इनका याद रखना है. रेडियस ऑफ gyration जो है, आप यू कैन वर्क आउट इन वन गो, यू कैन वर्क आउट, राइट. उसमें टाइम भी नहीं वेस्ट होने वाला. mk स्क्वायर, डिस्क और सिलेंडर एक होते हैं इसमें. mk स्क्वायर इज इक्वल टू जिसका भी मोमेंट ऑफ इनर्शिया दिया है, यू कैन वर्क आउट इफ दे आर आस्किंग फॉर रेडियस ऑफ gyration. एंड इफ रेडियस ऑफ gyration इज गिवन, तब तो कोई इशू ही नहीं है. तब तो आपको बेसिकली वो मोमेंट ऑफ इनर्शिया बता रहे हैं ना, राइट. आइदर वेज इट इज वेरी वेरी सिंपल. Okay, so question 2 is, and please do this very, very carefully. Question 2 is, find acceleration of cylinder if no slipping takes place. Okay, so this is similar to the previous questions we have done, except पहले क्या था कि ये जो प्लैंक है ये ऊपर था, अब ये प्लैंक नीचे है. हाँ, radius of gyration is basically another way of telling you moment of inertia. हाँ भाई, फ्रिक्शन इज देयर, तभी तो नो स्लिपिंग हो रही है ना. बट द लोअर सरफेस इज फ्रिक्शनलेस. दैट मींस दैट ये वाला जो सरफेस है ना, नीचे वाला, ये स्मूथ है. So you don't need to bother about friction from the floor. Okay? It is just friction. हाँ, यहाँ पे A is equal to R alpha नहीं होगा. And you have to figure out कि क्या relation है. मैं डर गया, राधिका क्या बोल रही है. यहाँ 0 and 2A वाला यूज नहीं होगा. उसका उसका सिंपल सा रूल ले लो ना. सिंपल सा रूल ये है कि अगर आपका जो रोलिंग ऑब्जेक्ट है ना, इट इज इन कांटेक्ट विद ए फिक्स्ड sort of a surface, then A is equal to 2R, A is equal to R alpha बिल्कुल वैलिड हो। लेकिन अगर वो सरफेस फिक्स नहीं है, फॉर एग्जांपल इन दिस केस, देन देयर विल बी प्रॉब्लम्स। नहीं, तुक्का नहीं मारना है, जैसे मैं कर रहा था वैसे करो ना। दोनों जो पॉइंट ऑफ कांटेक्ट है उनके एक्सेलरेशन सेम होने चाहिए। नहीं आंसर में, अच्छा ये लिख रहा है क्या? उसमें प्रॉब्लम क्या है कि m और m इक्वल टू 2m हो गया तो पूरा हो गया। माइनस का प्लस कर दिया मैंने, हाँ? अच्छा तो ये गलत। देख, चलो I'll draw the free body diagrams and then you do. You see, it is guaranteed that the plank which has a force horizontally towards the right applied on it, okay, nahin, it is guaranteed that this plank will have friction due to the cylinder in the opposite direction. ये guarantee है, right? क्योंकि अगर plank के ऊपर मैं force लगा रहा हूँ और friction भी उधर ही लग गया, ठीक है ना, तो लोचा हो जाएगा। अगर सिलेंडर ने प्लैंक के ऊपर फ्रिक्शन पीछे लगाया है तो सिलेंडर के ऊपर फ्रिक्शन, this is the FBD, that's it. So the equations that you will write down, I hope everybody has written down these equations. F minus M, sorry, F minus F is equal to MA1 and F is equal to capital MA2 and FR is equal to I alpha. ये लिखा है सब में। ये see the equations, they are not very big, they are very simple. इसमें अगर कहीं source of confusion है तो please ask me. Now the thing is the constraint. If you can figure out the constraint, and I'll give you a hint on that as well, the constraint is simply that the acceleration of this point, the net acceleration of this point, must be the same as acceleration of this point. Now using these hints, try to solve. बहुत बढ़िया उत्कर्ष. Excellent, Richa. Yes, that is the correct answer. Now, using the relation that you have written, these solve these four equations. Tell me the value of A2. नहीं, डिनोमिनेटर में जो है माइनस नहीं आएगा. ओ नहीं, दो कंस्ट्रेंट इक्वेशन नहीं आएंगे, एक ही आएगा. वेरी गुड सोनल. यस, गुड. लेकिन सोनल एक शायद माइनस साइन गड़बड़ है. आई मीन यू आर एब्सोल्युटली ऑन द राइट ट्रैक, बट एक माइनस साइन गड़बड़. नहीं जोहेब यार, कहाँ से आंसर निकाल रहा है? देखो, मैंने ये मैंने ये अज्यूम किया है कि इस सिलेंडर के सेंटर का एक्सेलरेशन a2 है और इस सिलेंडर का एंगुलर एक्सेलरेशन अल्फा है. प्लीज नोट द डायरेक्शन, राइट? वेरी particular about clockwise or anti-clockwise. And I have also assumed that the acceleration of the plank is a1. So this point at the bottom cylinder will have an acceleration a2, right? And this is due to translation. And it will also have an acceleration r alpha, which is due to rotation, right? We have been doing this for so long now. So the net acceleration of this guy, of this point, will be this, which is equal to a2 plus r alpha, right? And the net acceleration of point B, if I consider this as point A and if I consider this as point B, then A I have found A2 plus R alpha, AB is equal to A1. So A1 is equal to A2 plus R. This is the constraint relation. Right, so most of you got it almost, most of you got it correct. That's very good. And now I can solve this. So I can write uh, f by m minus f by m. Okay, I have written the value of a1 is equal to a2, which is f by capital M, plus r alpha. Okay, so this equation I can write as fr is equal to mr square by 2 alpha. So r alpha is equal to 2f m. So this is equal to 2f, right? So I will get f into 1 by m minus 2 by m is equal to 1 by m plus 1 by m into f. And these are one of the many ways of solving this, right? So f will be equal to capital F m minus 2m upon m plus m, क्योंकि दोनों fractions में जो denominator है वो cancel out हो जाएगा, right? So if this is the value of f, then I can find the value of a2, which is equal to f by m. Therefore, a2 is equal to f m minus 2m upon m into m plus m. Right now, I can ask the question. I can ask a very एक मिनट में गड़बड़ किया क्या?
सर वो नीचे उधर स्मॉल एफ होगा
हाँ
सर, वो एफ कैपिटल एफ अपॉन एम वाला इक्वेशन है ना, उसके आरएचएस में 2 स्मॉल एफ अपॉन एम होगा ना।
इसके RHS में
सर जो आपने एफ बाई एम माइनस स्मॉल एफ बाई एम लिखा है उसके
हाँ
RHS में 2f बाई एम जो है वो स्मॉल एफ होना चाहिए।
ओफ हाँ, सब गलत हो गया। भाई मैं सोच रहा हूँ एक्सप्रेशन जीरो क्यों आ रहा है m is equal to 2m। नहीं बता सकते थे क्या? सो दिस ये मैंने गलती
चैट
कर
तो बोला था
अच्छा बोला था क्या? मैं इधर देख रहा था ना, चैट उधर हाँ, हो गया। f by m is equal to f 3 by m plus 1 by m. So f is equal to f capital M upon 3m plus अभी सही है ना? So a2 is equal to f by capital M will be equal to f upon हाँ ये सही, जीरो नहीं आना चाहिए किसी भी केस में। ये उत्कर्ष तेरा यहाँ क्या, ये कैसे आया उत्कर्ष?
सर। इसमें फ्रिक्शन का डायरेक्शन लेना इम्पोर्टेंट है क्या?
क्यों?
मतलब फ्रिक्शन का डायरेक्शन में कंफ्यूजन हो रहा है कि वो कौन सी साइड पे होगा।
नहीं यहाँ पे फ्रिक्शन जो है वो एम्बिग्युइटी नहीं है कहीं पे। फ्रिक्शन में जहाँ एम्बिग्युइटी है वहां पे आपने कोई भी डायरेक्शन चूज कर दिया, कोई प्रॉब्लम नहीं। लेकिन यहाँ पे कोई भी एम्बिग्युइटी नहीं है। प्लैंक के ऊपर फ्रिक्शन को पीछे की तरफ लगना ही लगना है ड्यू टू द सिलेंडर, and therefore due to the plank on the cylinder friction must be in the forward direction. The point is that if you take the plank and if you move this, right, then this guy will have a forward acceleration. इसमें आपको दिखाई देगा relative to my hand it may be moving backwards, right? But if you look at the position of the cylinder and now if you look at the position of the cylinder, it has moved forward, right? So the acceleration has to be in the forward direction. Okay, so this is the most complicated question that I can think of, which may come in IIT wala exam. इससे ज़्यादा टफ नहीं आ सकता, इनफैक्ट ये भी नहीं आया। चलो, so before we ज़्यादा बचा नहीं, before we go, let me introduce you to work energy theorem in RB. Okay, very, very simple, because we know that everything that we have in the translational domain sort of copies itself in the rotational domain, right? So what is the work energy theorem? In translation. Well, the work energy theorem is that summation of work done is equal to change in kinetic energy, where work done is equal to plus minus integral of f dx. Now I know that the definition of work is more complicated than that, but I have taken a very, very simple one-dimensional kind of definition, because we have reduced the concept of torque also to one dimension, right? We are never going to deal with two-dimensional torque. If one dimension में ही नाक में दम है तो we can't. We are not going to go with two dimensions. So the reason why I have added plus minus is very simple. If the force and displacement are opposite to each other, minus. If the force and displacement are in the same direction, plus. And K, which is the kinetic energy, is equal to half mv square. Therefore, work energy theorem in rotation will be summation of work done by torque is equal to change in rotational kinetic energy. So let me write here summation of work done by forces is equal to change in translational kinetic energy, where translational kinetic energy is this, work done by a force. So in exactly the same way, we will write where work done by a torque will be equal to plus minus integral torque d theta, right? I mean, it is just a copy of what I have written above. And the rotational kinetic energy will be given by half I omega square. So work done by torque is either plus or a minus. It is plus, let me just write this here. So plus, if torque and d theta have the same sense of rotation, that means that both of them are either clockwise or anti-clockwise. Okay. And minus if torque and d theta have opposite sense of rotation. Okay. So work done by a torque is very, very easy to find out. All you have to do is simply integrate the value of torque. And I want to do that. So this is applicable. Let me just write this here. So this guy is applicable. This guy is applicable for for a body in translation. And ये जो मैंने यहाँ पे लिखा है, ये जो लिखा है, this is the new thing, right? So this, just like the things we have discussed before, this is applicable for a rigid body in rotation. Okay, and what do you think is going to happen for a rigid body in rotation and translation? We are going to apply both. We are going to apply both. But before we do that, I want to discuss this rotation one apart. So let's say that we have a rod of mass m and length l, and what we have done is we have fixed this fixed one end of the rod. ये वाला end हमने ऐसे fix कर दिया. The rod is free to rotate. Okay. The rod is free to rotate. So if the rod is released, then of course it is going to go down. And we will say that, look, at some point of time, the rod is like this, where it has traveled through an angle theta. The rod is here, angle theta se wo travel kar chuka. So in this position, we draw the FBD of the object. mg यहाँ से act कर रहा है और कुछ तो normal reaction यहाँ से act कर रहा होगा. I don't care about it because I'm going to take that fixed point as the origin, and therefore the torque about that point of any other force acting on that point will be zero. So whether there is friction, whether there is normal reaction, which is definitely here, I don't really care about it because I'm going to take the torque from this point. Right? This point is where I take the torque from. So if I write then torque about point O, it will come out to be mg into L by 2 cosine theta. Right? And we know now that the work done by this torque is equal to integral of this torque d theta. Right? But first we need to decide whether it is plus or minus. So in this case, the work done will be plus, because the torque is clockwise and theta is clockwise. ठीक है ना? एंटी क्लॉकवाइज नहीं है तब, दोनों क्लॉकवाइज. देखो ऐसे क्लॉकवाइज. So plus integral of mg L by 2 cosine theta d theta, and I'm taking this from 0 to theta, and this is a very, very simple answer. Work done by torque is equal to mg L by 2 तो बाहर ही आ जाएगा. इंटीग्रल ऑफ कोसाइन थीटा डी थीटा साइन थीटा होता है, और जब मैं 0 to थीटा लिमिट डालूंगा तो साइन 0 0 हो जाएगा. तो दिस विल कम आउट टू बी सिंपली दिस. But I can write this as mg into L by 2 sine theta, which is equal to what? What is L by 2 sine theta in this diagram? What is L by 2 sine theta in this diagram? Well, L by 2 sine theta in the diagram is the distance or the vertical distance traveled by the center of mass. So the vertical distance traveled by the center of mass is equal to L by 2 sine theta. Let's say that this is equal to h. Right? Let's say that this is equal to h. So then I get an astonishing result that work done by torque due to mg, or work done by torque due to gravity, is nothing but mgh. In fact, I can give you a guarantee, right, that you will never, maybe once or twice, definitely not in the IIT paper, definitely not in the mains paper, you will never ever have to carry out this integration again. Unless of course the question बिल्कुल force कर रहा है कि नहीं ये torque है इतना angle है बताओ work done कितना हो. But you will never ever have to work out this integration. All you have to remember is that work done by torque due to gravity is mgh, where h is the vertical displacement or the the ये center of mass यहाँ से यहाँ आ गया. Does not matter. We are only looking at the vertical height traveled by the center of mass. So I can now write that work done by torque due to mg, right, is equal to plus minus mgh, but this is a result that we have been seeing for so long. It is the work done by gravity, it is the potential energy of gravity, and now it turns out that if gravity is applying a torque, then it does the same amount of work. Plus कब होएगा, minus कब होएगा? Plus when it is going down, okay, and minus when it is going. So if you see that there is an object, there is a rigid body which is rotating, इसका मतलब एक point कहीं fixed है, and it is rotating under the influence of gravity, right? Then you forget about work done by torque, you forget about integration and everything. You just see the initial configuration of the rigid body and the final configuration of the rigid body, and you just equate it mgh, you just find h and you just say that work done by torque is equal to mgh. So now I can very quickly show you what the second part of the question will look like. So I can say that, look, if the rod is released from the horizontal position, then find its velocity, find its angular velocity when it becomes vertical, right? And we are assuming, of course, that there is no friction. So when I release this rod from the horizontal position, what is the angular velocity that it has when it becomes vertical? Very, very easy. Okay. So work will be done by torque due to mg, and that will be equal to plus mgl by 2. The moment of inertia about that fixed point will be equal to ml square by 3. So this implies that mgl by 2, which is the summation of work done, is equal to final kinetic energy minus initial kinetic energy. So we get mgl by 2 is equal to half ml square by 3 omega square. ml cancel हो गया, and we get omega is equal to 2 भी cancel हो गया, 3g by l. वर्टिकली बिलो कहाँ है? पहले यहाँ था.
सर जो आपने डायग्राम बनाया है,
हाँ वहाँ पे वर्टिकली बिलो नहीं होगा. बिल्कुल सही. बहुत वेरी गुड. यस. सो दिस इज अ वेरी एक्सीलेंट ऑब्जर्वेशन. ये वर्टिकली बिलो नहीं होएगा, थोड़ा सा ऑफसेट होएगा, लेकिन वर्टिकल डिस्टेंस बिटवीन द टू विल बी इक्वल टू mgl by 2.
सर लेकिन l/2 sin थीटा नहीं होगा ना?
होएगा ना l/2 sin थीटा. देखो ठीक है. अभी ठीक है ना?
हाँ सर.
मेरे को आप ये बताओ कि ये डिस्टेंस कितना है,
l/2
ये एंगल कितना है,
थीटा.
ये लेंथ कितनी होगी, ये लेंथ कितनी होगी?
L by 2 sin theta.
Right, and this is also the vertical distance traveled by the center of mass.
हाँ सर समझे.
Actual path followed by the center of mass is गोला, बिल्कुल सर्कल है. But जो vertical drop है, that is
Okay sir.
okay. So this will be the angle. How you apply this work energy theorem? Objects. ठीक है, ओके चलो यहाँ पे let's end here. Next class में we should be able to then start angular momentum, and which is the last part of this huge chapter. सबसे बड़ा chapter है. हाँ, HCV now you can do. HCV में क्या प्रॉब्लम है? I'll tell you. HCV में जहां तक आपने किया है ना, उसके बाद एंगुलर मोमेंटम शुरू हो जा रहा है. जहां पे एंगुलर मोमेंटम खत्म हो रहा है, उसमें एग्जैक्टली ऐसे ही क्वेश्चन दिया हुआ है. ये रॉड वर्टिकली हॉरिजॉन्टल से टेढ़ा हो रहा है, वहां से you can start with. Right? So if the question mentions angular momentum or there is a collision, then you skip those. I think that starts from around 49 and goes up to around 65 or something. After that, you have the work energy situation. Work energy. Okay. Oh, chalo, ठीक है. So, am I supposed to end the class or are you continuing?
End the class.
End करना है ना?
हाँ सर.
चलो, ठीक है भाई. चलो, बाय बाय.
Bye sir.
थैंक यू सर.
Bye.
Thank you, sir.